For decades, underground structures showed great resistance against earthquake that made the engineering society to believe that they are naturally safe, like superheroes of infrastructures. Earthquakes? Nah, tunnels got this. But what if they don't? 1995 Kobe earthquake, Japan, and the collapse of the metro system. This can also happen here in Canada. And then imagine the ripple effect. Lots of people will seek for plan B, probably cars, and we will have worse traffic, fuel consumption, and a surge in the carbon emission. And we also need to spend time, money, and massive resources to rebuild everything. This is exactly where my research comes into the picture. With the results of this research, we can find the weak links and fix them in advance. We can modify the design codes, and we can build a more resilient city. Did you know that Canada experiences more than 5,000 earthquakes annually, most of them minor in magnitude? Western Canada is known for its seismic activity, but there is also another area here in Eastern Canada where we have cities like Toronto and Montreal. Seismic activity here is not as intense and not as frequent of Western Canada, but the risk is still unique. Why is that? Because we have a highly populated area here, we have aging infrastructures, and we have a specific soil condition that can amplify the seismic waves. Yet, research on seismic response of tunnels in Eastern Canada is lacking. Understanding the seismic risk goes through three elements. First, hazard. How likely is that even earthquake happening here? Second, fragility. How is the probability of the structure to be damaged, and then the consequences? What will be the consequences of that? Fragility itself is a complex part of this research. It's like solving a complex puzzle that we need to understand the effect of different pieces, like depth of the tunnel, the concrete properties, the soil or rock material properties, and the interaction between the structure and soil or rock. To do so, we build a comprehensive framework. First, we collect data based on common scenarios, site-consistent material properties, and earthquake records. We do sampling to get the variability in different parameters like the burial depth of the tunnel and material properties, and we generate thousands of numerical models to build a comprehensive database of the tunnel's response. Then, we use machine learning techniques to quantify the damage and establish the relationship between the damage and different parameters. Then, we calculate the probability of the damage. What will be the probability of damage based on different parameters? Up to now, some cases show that while some tunnels are pretty safe, there are cases that are more vulnerable and need more attention. Then, we conduct an expert-based survey to assess the risk. If my research can find even a small weak links in between the kilometers of the metro system, and then we can fix them in advance, then it's totally worth it. Thank you.